In this question, there are two blocks connected by a cord and it's passing over a frictionless pulley, and this arrangement is known as the Atwood's machine. So we have two blocks, we have mass M1 and mass M2, and then you can see that M2 has a greater mass than M1. And the question is, what is the magnitude of the block's acceleration and what is the tension of the cord? So as you can see that M2 is going to be moving downwards and M1 is going to be moving up. And then let's look at the forces acting on each block. So M1, we have W1 down, and the tension is always away from the object. So here it is T. And for M2, we have a W2 and away from the object. So tension moving up like that. And since these blocks are not on a surface, we don't have normal force for either of them. So if we write F equals ma in the y direction for both, because they are both moving in the y direction, so let's just write this for M1 first. So we have Fy equals MAY. What we have is positive T, negative W1 equals M1, because it's the first block, times A. Now is acceleration positive or negative? We took positive y as upward, and as you can see for M1, A acceleration is upward, so it is a positive A. Let's call this equation 1. And then if you look at M2, let's do summation of y. Fy equals MAY. So we have positive T and then negative W2 equals M2, because we are looking at the second block, and acceleration is negative because we have A pointing down and our positive y direction we chose earlier is positive. So this is negative A. And let's call that the second equation. Now what we need to do is to solve these two simultaneous equations. So from the first one, you can isolate T as M1A, and that's the right hand side, and then we can take the negative W1 to the right hand side, so that becomes positive. And then what we can do is, for the second equation, instead of T, we can write what we just solved for T. So T here is, we have M1A plus W1, and then that's our T. So now we have minus W2 equals minus M2A. So W is weight, which is mg, so this is m1g, and W2 is m2g. We have m2 times A. So let's isolate A. We isolate A, we have m1 plus m2 from the right hand side, we bring it to the left hand side. And then let's take m1g minus m2g to the right hand side. So what we have is m2g minus m1g. And if you solve this equation, so that what we have here is m2g minus m1g divided by m1 plus m2. And if we plug in the values of m1 and m2 and g, which is 9.81 meters per second squared, what you will get is 3.6 meters per second squared. And then you can plug this acceleration value to any of these equations and find the tension. So let's look at equation 1 here. So we have T equals m1a plus w1, so which is equal to m1 is 1.3, acceleration is here 3.6 meters per second squared, and then plus w1, which is m1 times g, so we have 1.3 again times g, which is 9.81 meters per second squared, and then that should give us T equals 17.4 newtons, and that's the tension in both. The most important thing in this question is to remember that acceleration is negative here. Otherwise, if you put a positive value here, you'll get an acceleration of 9.8, acceleration of gravity as the answer, and then you'll know that that is not correct.